Physical AI is one of the most hyped and most misunderstood areas of tech right now. Robots, autonomous vehicles, warehouse systems, the gap between the headline and reality can be enormous. Fortunately, our next panel is going to help cut through that noise. Please welcome to the stage our moderator, Amelia David, senior reporter at VentureBeat, and panelists, Oana Jinga, co-founder and chief commercial and product officer at Dexery, Gautam Narang, CEO and founder of Gatic AI, and Heather Carroll, CRO of Path Robotics.
Good morning, everyone. Thank you so much for coming. I know they couldn't let you all bring coffee. I should know because I only had like 3 sips. So bear with me. I also just ran from the subway. This is going to be a very interesting panel. There's a lot of interesting developments within the realm of physical AI, but there's also still a lot of, in my opinion, a lot of confusion over what exactly it is. And I hope that this panel would really shed a light on where, and how it's going, the development of the technology. And I think the best place that we could start is if I could just ask my panelists to introduce yourself, tell us about your company, and also what does physical AI mean for you and your company? Yeah.
Sure. Good morning, everyone, and thank you so much for having me here. So Oana Jinga, I'm a co-founder and chief commercial and product officer at Dexery. Is quite a long kind of title there, but pretty much means I look after revenue and product roadmap and strategy. And within that product roadmap and strategy, obviously the whole physical AI theme is definitely at the center. But I think if I take a quick step back, at Dexery, we've been in the robotics space for almost a decade now. So I just love the fact that all of a sudden, over the past 6 months, it's become the most interesting thing that everyone wants to talk about. It's like, we've been telling you this for a decade. So very excited to be in this space. And pretty much what Dexery does, for those of you who don't know, we use autonomous robots. They're very, very tall autonomous robots. They can go up to 60 feet. And we use them to digitize warehouses. So they scan warehouses continuously, capturing all the information about the goods, the space, the racking, the distances, people, machinery, so everything kind of that happens inside a warehouse, and produces kind of real-time digital twins of exactly what you have in a warehouse. So we're pretty much bringing that physical world into a digital format, so our users and customers can very simply kind of interact with it and understand what they have where and find ways to make it more efficient. So where the whole kind of physical AI element comes in for us is exactly in that. I mean, when you think about the way you use like ChatGPT or Claude or whatever kind of LLM you're using today, obviously you're asking it some questions about various different things that you have to do, and it's giving you some answers based on the amount of digital data that exists in the World Wide Web and above, right? So that's a lot of data. But when it comes to the physical world, if you want that thing that you're asking the AI to be an action or something about the physical world, well, that physical data just doesn't exist yet. So what we do is we actually kind of bridge that gap. So with the way we digitize the warehouses, we're actually kind of providing that data layer that you can then interact with very, very simply, and then have an answer that provides a physical action. So it's no longer just like, okay, I can write an essay now or an article using AI, but the action itself is a physical action. I'm going to move this pallet from A to B. So obviously that means that the information I have about that pallet has to be very, very accurate. But we could talk more about that.
Great. I'm Heather Carroll with Path Robotics. And what Path does is we have built a foundation model around millions and millions of inches of real-world welding data in manufacturing. So what we've been able to do over the last 10 years is create this data flywheel with implementations that we have of robots out in the field that we are teaching to learn to weld like a human. So how can we teach that robot through physical AI to be able to see the part that's in front of it, understand exactly what it's looking at, because the parts are not perfect. That's been solved. That's your pre-programmed welding robots that have been in automotive for 50 plus years. Comes on a line, everything's perfect every time. That's not what we do. You don't need physical AI for that. What you need physical AI for is 80% of the rest of manufacturing in this country, which is not perfect. It has flawed parts. They do not have perfect fit up. They are very large. They can't fit in a fixture. You can't move the part along a line and bring it to the robot. You need to take the robot or the worker to that part. That's the power of physical AI. And we are at an inflection point in this country right now where we do not have the skilled labor to solve this problem. I just came from DC yesterday where I spent the day with the PAE Maritime Group for the Navy. They launched their shipbuilding plan on Monday. If you pay attention to the news, you know we are in a very serious point in time where we do not have enough ships. And what do those ships need? They have to be welded, every single one of them. We're short about 400,000 welders right now. If you look at those plans and the $1 trillion additional dollars in budget that's flowing in, it's getting even worse. I also spend the other part of my time at Path talking to people that build data centers and infrastructure, because all of those components have to be welded. Backup diesel generators, the 9 to 10, 12-month lead time we just heard on BESS systems. You know why? Because the containers the BESS systems are held in all have to be welded, and there are no welders out there to do this work. And that's what Path does. That's the power of physical AI, is being able to enable a robot to be able to think, understand, and act like a human. And we can augment the need that's out there for the skilled labor.
And we'll definitely touch on that again later. Gautam?
Yes. Hi, everyone. My name is Gautam Narang. I'm the co-founder and CEO of Gatik. So at Gatik, we do driverless trucks for regional logistics network. So think of us as helping some of the largest retailers, grocers, to move goods from their distribution centers or warehouses to a network of retail stores. Just a quick background on my journey in robotics and physical AI. So I had a very early start. So been doing robotics since a very young age. This was back in 2006. So spent the first few years doing research on humanoid robots and legged robots. And I say this jokingly that I was 15 years too early to humanoids. And then in 2010 is when I transitioned to self-driving vehicles and mobile robotics. So spent a couple of years at Carnegie Mellon, got a chance to work on CMU's self-driving platform, and then started Gatik back in 2017. And then over the last 9 years, we have, I would say, hit a lot of exciting milestones. And one of the things I'm most proud of is the fact that we have truly driverless trucks running on public roads across multiple markets and multiple customers. So we announced this milestone recently where our trucks are running across highways and surface streets in Texas, Arkansas, Arizona for some of the largest brands, and all, again, no driver, no observers, all in a commercial capacity.
What's fascinating is that all of the industries that all of your companies play in are those areas that are either always looking for people to work for them, or there's been a little bit of a shortage. And Heather, you had pointed this out. There is a lot of shortage in skilled labor in so many industries, but there's this still a prevailing perception for so many people that robots, and in their heads that's automation, would take over a lot of jobs because it does a lot of things better. So I'd love to hear all of your thoughts around the idea of how is physical AI actually able to shore up those labor gaps that we have, while also still ensuring that people who do want to work in these spaces can work, and why this technology in particular? Anyone can start.
I'm happy to take that one. I'd tell you this. When I got the call to move from retail supply chain logistics, which is where I spent most of my career, over into manufacturing, I had to think really long and hard about it because I didn't know anything about welding or manufacturing. But when I got married 32 years ago, my husband was a welder. And I saw him come home every night. I know how hard that job is. Later on, fast forward about 20, 25 years, he started his own manufacturing facility. And boy, was that hard. Because why? He couldn't find any welders. So when I got this call that, hey, let's take this technology you've worked in forever and and solve a problem where people cannot find this labor. I get this question all the time, but there aren't people there. We don't have droves of welders lining up to take these jobs. It's brutal. It's dangerous. It's dirty. It's hard. And so what we have found, one thing that was really important to me was that our teams, our customer success team, start interviewing our Path customers and get them to collect the data. When you put the Path system in, what's your labor numbers? How many people did you fire because you installed that robot and because you installed that system? Every single one of them gone up. Their employees have gone up. And why? Because they weren't able to install a second shift before because they couldn't find the people. Now they can put the robots in, they can run a second shift, keep the people they had, and they've got to hire more people to support the second shift. And they can take in more orders. And that's how we solve this problem. We've got to actually talk about the data behind it, and we've got to share this instead of these narratives that are scaring people, because it's just not the reality of what I'm seeing on the ground with mid-sized manufacturers across the country or at shipyards that have hundreds and hundreds and thousands of openings right now.
Well, I was just going to build on that because I think it's exactly the same for what we are doing. First of all, in terms of the actual automation of a task, the only thing that we do automate is kind of inventory taking or cycle counting, which would require somebody in a warehouse to go literally location by location, count how many boxes, write on a piece of paper, input that into a system, which if it was all kind of floor level, you'll be totally fine. But we're talking about going up, like up to, all the way up to kind of 18 meters, 60 feet.
It's also dangerous to be in those three thingy.
Exactly. So that's exactly what I was going to say, which is like, there's been a lot of accidents. I'm actually very surprised every time I hear like how bad things are. So that people actually don't want to do that. So the moment we come in and say, okay, we're going to take all of that away. So what you will be able to do then is actually kind of look at this data, work with the data, and become a lot more of a kind of a data scientist rather than literally somebody who counts boxes, which is very, very boring. So from that perspective, we've had so many examples where that has happened. And we have case studies with people saying like, I'm loving this because I could do a lot more with it. But the other thing I was going to say, I know like robotics in itself, because it does have that physical element, has this kind of reputation in. But I think what we're actually seeing, what happens on the digital side with AI is, to me, is a lot more dangerous, right? So I think it's kind of like having to balance the two. So from a physical AI perspective, we're seeing the contrary.
Yeah, I think for us, I'm sure everyone is very aware of the driver shortage that we are seeing in the trucking space, right? And the stats are staggering. So similar to the other applications, right? We too are seeing a huge driver shortage. So the latest number is over 100,000 truck drivers are needed in the US today, and that number will increase significantly in the coming years. And maybe just to share the reason behind that increased demand, right? So what's happening is all of us, we have been pampered, right? So we expect our orders as soon as possible, as cheap as possible. On top of that, we want the best customer experience. And given the extreme driver shortage, our customers, which are retailers, grocers, they have to turn to automation, right? And on top of that, the freight volume is also increasing. So the latest stat there is the volume will increase 50% by 2050. Again, it's all driven by end consumer expectation. So automation is the only long-term viable solution here. And I think very similar to the other applications, there are new kind of roles and jobs that are being created, right? So things that let's say are needed to support autonomous trucking operations, remote supervisors, technicians, maintenance staff, operations staff, all of those things are bringing new jobs to the industries that have not seen this kind of high quality of jobs.
I'd be remiss if we didn't also touch on this AG. We should talk about this a little early. There's, for so many people, like Una mentioned, there's this perception of what robots can be. I had done a robotics fellowship, and there was, of course, a robot dog, and I'm just not fond of them. And I feel like that's because of a very specific Netflix show. But there is this kind of perception, because it's so unlike what we're seeing with like the video AI that we're seeing, it's like the uncanny valley isn't as scary as much as like that's just weird. It's a physical thing. It's a robot. You can touch it. It walks towards, actually stalks towards you. How do you kind of battle with that perception? Because that is not all of robotics, right?
I could probably just take that to begin with because, I mean, first of all, we've always kind of believed from the beginning to actually kind of have a form factor of a robot or a technology, let's say, because it's not even necessarily kind of like a robot per se, that would be very suitable for a particular use case that you're building towards. So our robots have nothing to do with a human form in any shape.
When you said it was a really tall robot, my first instinct was no, and then I remembered, no, it's not that.
Yeah, so it's not a very tall human that goes up to 60 feet, no, but it's a kind of an autonomous base that has a tower with a telescopic kind of element to it with a lot of cameras and sensors, and it's been designed like that to be able to robustly work inside the warehouse and have a lot of cameras and sensors to capture data, right? So I think we at Dexter, like we've always kind of, and all the different kind of shapes and sizes we've done across the 10 years in robotics, everything we've done was very particularly focusing on whatever use case you have to do. So, I mean, will humanoids become a thing in the next decade? Potentially. I still feel like the human body is very fragile and it shouldn't necessarily be replicated if you don't have to. And what's interesting is actually when you see most of the videos, like you were saying online, you see humanoid robots doing things in like pristine factory floors or like perfect warehouses. And I'm like, well, you don't really need to be able to have legs and walk in there, right? Because if it's so smooth, just put some wheels, make it kind of a third of the cost and just like get it running much better, right? So everyone talks about the human form factor that will fit into whatever human like work environments or homes we have right now. But obviously to get there is going to be a very, very long journey. And the missing piece as well is, going back to what I was saying earlier, is having that physical data to be able to train these humanoid robots on. And that physical data doesn't exist yet. So yeah, it's going to be a pretty long journey to get there.
Yeah, I think, I have very strong opinions on humanoids and how the industry is shaping up. The framework that we have used always is function over form, right? So what problem you're trying to solve, and what is that the right or the best form factor to address that pain point, right? So I think roboticists fall into this trap where they try to build the coolest technology, in my opinion, without spending too much time in the field or interacting with the customers or really understanding the problem that you're trying to solve, right? And it's not just humanoids, but robotics more, or physical AI more broadly. So yeah, so I think form over function is, function over form is how to go about thinking, do you really need 2 legs and 2 arms? Why not 3 arms? Why not just 2 cameras or 2 eyes? What about a 360 vision?
I'm sure you've gotten are there robots behind your trucks kind of conversation.
Well, eventually the whole supply chain would be automated end to end. Today we're automating the driving fees. I'm sure, there are companies that are automating what's happening and how goods are flowing inside the warehouse. I think that future is within sight. Mm-hmm. The question is what kind of environment are you deploying these robotic systems in, right? Are these structured environments, semi-structured, or fully unstructured? A lot of promise with general purpose robotics or humanoid robotics is, it's going to be very versatile. So it's going to be able to handle different kind of tasks in very unstructured environment. Because in structured environments, you would need a very specific form factor, right? You don't really need that versatility that comes with a humanoid form factor.
Yeah, I would say it is absolutely what is the use case. For Path, we started out with our physical AI model working on a fixed 6-axis robot because that's what's typically out there in the industrial market doing manufacturing. But our model has always been that we do not care what the form factor is. It's whatever is the right application for the job. So just a few weeks ago, we launched our first mobile platform, which is currently on a quadruped called Rove. Rove went viral pretty quickly within a few days of having the video post up. We had over 5 million views, and we've already taken in excess of 25 pre-orders in about a week and a half or 2 weeks from companies that range from data centers, so people that are building these big backup diesel generator tanks, to mostly shipyards. We have 4 different shipbuilders that have signed on already. And the reason is the form factor can get to the work. So it really is it's more about that. On the data center piece, what's interesting is a lot of these components are being made by fab shops, mom and pops, mid-sized manufacturers all across the country that the GCs are then subbing out these different components to. And they don't have the footprint. They got 100,000 square feet that they've been doing things the same way they've always been doing them. And now you're asking them to come in and build something that's 60 feet long for an e-house and 20 feet wide. They don't have the space for that, and we don't have the time to wait for every mid-market manufacturer to build a new building just to build the parts to build a data center. So we got to leverage the network of manufacturing that we have, and the way to do that is to allow more flexibility in the automation and the robotics to be able to have different form factors to fit into the brownfield spaces that are out there. And that's why you see this leaning towards something that looks more like a human form, because that'll fit on where I have space today, where the humans are. But that's not always the best answer.
And speaking of like the deployment in the unstructured environment that they all move around in, one of the more interesting things that has happened in the past few years is kind of the melding between physical AI and what's generally more software AI, things like generative AI, mostly foundation models. We're at an age where it seems like there's a lot more conversions of the two. I'm interested to hear first, what impact have LLMs and that general idea around foundation models have had on the development of all of the physical AI projects that your companies have been doing?
I think for us, it does come down to scalability and generalizability, right? How scalable your core technology is, and how generalizable is it? Like, what kind of environments that our trucks can handle driving in. So over the last 2 years, the speed at which we can unlock driver out operations in a new market has accelerated. And a big part of that is we are now doing a lot of work in simulation, right? 2 years back, we decided to bring simulation in-house. So today, we can start generating very accurate digital twins with very high fidelity across different sensors that we use, right? LiDARs, cameras, radars, even without having our trucks physically on the ground. So all of a sudden, you can create scenarios, test out different edge cases in a market without having to run the trucks and having those real-world driving miles, right? So think of this as you can now augment thousands of miles of real-world driving data to tens of millions or hundreds of millions of synthetic data that is highly accurate. And so the cost of data has come down drastically. The speed it takes you to do safety validation, proving that your system or technology is safe enough or good enough for you to pull the driver out, has also come down, all because of the advancements in the AI space. And the architecture of the models, they have gotten quite advanced in a way that it's less about technology or proving that the technology works or not. It's more about what scale can you achieve, how quickly can you scale, and then I think the focus is very much on operations for us, which is, the need is there, the technology works, how quickly can we scale and handle the operations?
I can kind of talk from our perspective. I think, first of all, everyone kind of, when they initially talk about AI, it's kind of like you just said, people think about LLMs, but AI means a lot more than that. And there's been a lot of advancements outside of LLMs that we are very much kind of using day to day. So to kind of put it in very practical terms, for instance, like the way that robots navigate and how safe and accurate and precise they are with that navigation to be able to position everything that we're scanning with like millimeter accuracy inside the warehouse. That's been something that's been kind of being in development extremely well for the past 12, 24 months. Even the prices of LiDAR sensors have kind of gone down, but their capabilities have gone up. And then a very kind of big area for us is also the advancements in computer vision and perception. So we do take high-resolution images in every single pallet location inside the warehouse, and we also kind of capture the racking structure in 3D, the volumes and shapes and sizes of goods. So for instance, a couple of months ago, we launched a new feature that we call Storage Health that pretty much can do all the health and safety work that a normal health and safety worker would do inside the warehouse, going aisle by aisle and identify kind of anything that might fall down or like might cause an accident, down to kind of like little cracks in the actual beams of a rack, right? So being able to now have eyes all the way up inside the warehouse is quite magical, considering obviously before you were quite limited in what you could do. So it's, yeah, that's something that obviously wouldn't have been possible like 6-7 months ago, right? To be able to do that on the edge, and we're talking about like hundreds of thousands of pallets, it's not like 10 images that you send to a cloud, right? The other a big one as well, like if we do move into the LLM side, we launched another product called X0 Adapt that actually allows you to interact with the data that we bring, plus the data that the customer has from different systems, plus now tapping into the worldwide knowledge base of kind of warehousing best practice. So when you bring all those three together, you make kind of the information you're giving very, very contextual to exactly what's in the warehouse on that particular day. So simple things like help me make space for like another 5,000 pallets that are dangerous goods, this weight, and kind of can't be next to, let's say, gluten-free products. And at the tap of a button, you kind of compute everything and kind of like, okay, these are the actions you have to do, move this from A to B. And in 20 moves, you kind of create that space. So it's a combination of different elements of it. It's not just the LLMs themselves, but yeah, we could do so much more with the data that we capture by utilizing the technologies.
Yeah, I think I would answer it. I'll take a different avenue on the answer. It's made conversations like this possible with people like you, because now that we've kind of are this post-Chat GPT era where lots of companies have invested heavily in LLMs, and we have this generative AI capability, everybody plays with it, now we're starting to get some use cases with it. There is this awareness that the way that's possible is because we're able to go out and scrape all this data on the internet. You can't do that with physical AI. You cannot do that with welding. You actually have to have the real data of what happens when you put two pieces of metal together and you try to meld them into each other. And Path's been working on this for, like I said, for the past 10 years. So we have 8 years of this massive data set that we've collected to train this model. LLMs, the other side of this answer is it does nothing for us because the data doesn't help us. We have to have our own weld world model and our own foundation model that trains on that with real data. But what it has done is it's made people aware of the use cases that are possible. It's made people aware of the need to take something from generative and actually get into the physical world to do something tangible with it. And it's helped open up discussions with investors to really look at what the potential is here to use this in a very tangible way to solve real world problems.
If I could just add to that, I think the point that you made around conversations being so easy. I mean, there's a few like big logistics events I'm sure everyone knows. Like I was in Modix in Atlanta a couple of weeks ago, and we're talking about kind of this whole X0 Adapt. Like you can ask it questions and it'll tell you things. Like every single person that stopped there at stand, regardless of the role they had in the warehouse, they got it instantly, and they started interact with it so like flawlessly and naturally. And to me, I was like, oh my God, like literally, like last year, this time, there was no way you could have been able to launch something like that because people are like, okay, this is a bit crazy, right? But you're so used to using these platforms that, and that's kind of across everyone, right? That it's just going to make conversations a lot easier, and you could introduce these use cases much, much easier in the actual operational floor rather than, okay, have to kind of like do all the trainings and get people to push it from the top down.
Yeah, I think like, we've had like, very similar experiences as well. The kind of like, customers that we target are like, retailers, grocers, CPG companies, right? And you can imagine 3 years back, no one believed that physical AI was a real thing, right? Like, obviously everyone was very focused on automation in the digital world. And now those conversations are very easy because, like, the folks that we are talking to, they're getting a lot of, like, questions and, pressure from the top in terms of, like, what are we doing about automating, like, in the physical space. So, yeah, now physical AI is now more mainstream, and it has made the conversations with the customers and the kind of customers that have very traditional industries, like, easier. So
yeah, it's definitely gone from we're going to put an innovations budget together for a pilot to it's a board level conversation now.
And I assume also this growing comfort with AI in a lot of different forms. I know before Waymo really started, there's a lot of conversations around why do we want a driverless car going around San Francisco? And now I was in a dinner and someone had told me they feel safer in a Waymo than an Uber. So has that also impacted how when you go into these customer conversations or even partner conversations, there's just more understanding and comfort level of and sophistication over what you're trying to present to them?
Yeah, I think like the safety is like somewhat paramount when it comes to like AI, right? And it all depends on whether your application is safety critical or not, right? So we're talking about LLMs, hallucinations, or like wrong output is somewhat acceptable in that world, in that environment. We cannot afford to have like wrong output from the AI model. So we have to balance out like the scale and generalizability that comes with the AI models, with the surety that you need, with the kind of like applications that we are focused on. So safety is paramount, and the way we think about that is we cannot make mistakes, right? One mistake for us will take the whole company down, and if not, like obviously the industry, we have had instances in the industry where it's somewhat like set the industry back. So but the kind of scale that we're operating at, it's like very important to ensure that there is safety during the development phase and also during the deployment phase. So, right, when you have physical assets in the field, in safety critical environments for safety critical applications, like how do you go about ensuring all the things will work together? And that's the big task ahead. And yes, Waymo has done a great job, I would say, getting everyone comfortable with the fact that this technology is safe, can be safe at the scale that where it starts having real impact.
I mean, obviously you guys work on the streets with Waymo, but it's exactly the same inside the physical warehouse. There's just so many other robotics companies out there that do picking or moving pallets around and so on, that it's probably quite similar in the sense that people are much more used to having robotics around and working in such an environment. But I do have to echo, there are some kind of clear safety standards that you have to adhere to, and I think what's been a lot easier now is because of all the technology that kind of existed for a while, most of our customers have a pretty good idea around like, okay, this is kind of what I need you to meet. We're like, yep, this is we're meeting it, here's our certification, great, let's kind of carry on and not kind of like focus on that too much. But we also, we do a lot of work once we actually are on site with the whole team there to kind of explain, okay, this is the robot, this is what it does, like this is how it's going to act when it encounters like a picker or like a forklift, or if you have any kind of concerns whatsoever, these are the emergency buttons we can press and it's just going to get away from you or stop. So you kind of have to still work with the people on the ground just to make sure that they're comfortable to be in that environment. And I think the other element as well is, I mean, with any newcomer in a space, I mean, we've only been operating in warehouses for about 3 years now. And initially, apart from the fact that to your point, everyone was like, oh, this is never going to work, like, what is this thing? So you have to kind of build a little bit of that credibility. After that, of course, the more examples and case studies you have, then the more at ease people are because they know that you're working with some of the biggest players in the market. And I think to your point earlier, like, I think we now kind of scanned over 1 billion pallets, and we're adding like probably 2-3 million every single day. So that's also something that kind of makes people quite comfortable. Okay, like, yeah, this is working. There's not been anything kind of urgent that we need to worry about. So you have to build a little bit of that credibility.
Yeah, I would say on the safety side, particularly around the model and the outputs that it creates, it's an interesting thing with welding. I'll give an example. We have customers that do utility poles. So they build the poles that take the power lines and the transmission lines, to the data centers and to all of our homes. And whenever you're going to be putting something like that over a playground or over an interstate, you've got to make sure the weld at that base plate is good. That weld is not going to fail. So there are all kinds of requirements and standards that have to go into that. And it's called a WPS. It's a welding procedures standard that each manufacturer has to have, that then has to be tested with ultrasonic testing to prove that the inside of that weld is good. We're fortunate. We have all those safety standards that we can then use to determine and help the model determine what is good and bad. And so in a lot of cases, you don't have that. You don't have those guardrails in training models for AI, but in welding you do. So it makes it this really interesting case where we actually, it's this one little area of manufacturing where you know what good looks like, and you can build that into the policy networks and into the model training. So in some ways, it's going to have a greater output and greater outcome, and we're seeing that in the numbers in what's called first pass yield. So first pass yield is you weld a product, it comes off the line, it goes through inspection. How many of those products pass that inspection with ultrasonic and visual testing against those standards? And in the utility pole industry and world, the industry average for manual welding is about 60%. So you think of these 80-foot long utility poles that are 6 feet in diameter, and 6 out of 10 fail. Imagine how much footprint that takes up in your factory. Those things are enormous. You have to have these big cranes to move them around. So 6 out of 10 fail every time. So when they fail, you have to have a grinder come in, and they have to grind the whole weld out. And on a base plate, it's a multi-pass weld where they might have welded 22 passes. Now they've got to grind that whole thing out. It takes an entire shift, and you're doing it 6 out of every 10 poles. This is why we have backlogs with data center and infrastructure grid stuff. The stuff's hard, but with our models, our customers are seeing 98 and 99% first pass yield. So within the same footprint, you're getting 9 out of 10 poles out of there instead of just 6 out of 10. So the safety piece, when you think about it in terms of how you can train the model to produce safer and better outcomes for the overall product, is really impactful too.
Yeah, I think for us, in our industry, there are no specific, I would say, safety or performance metrics that companies like us can be evaluated against, right? So everyone is somewhat like, using their own metric, and like there's a lot of misinformation in our industry of like, what is good enough or what is safe enough. And there is like regulations, there are regulators, but it's very, I would say, light touch, and safety is like, all the companies are handling safety on their own. And one of the frameworks and philosophies that we have adopted is to get all the stakeholders to the table, right? We as the AV developer, our customers as the adopter, local regulators, state regulators, and policymakers, and coming together and defining what is that acceptable bar, right? Like, what is acceptable risk. So in the absence of like proper standards, that's basically the framework that we have adopted. And I think one of the philosophies that we have also used is giving independent safety auditors access to how we have developed the technology and how we're deploying the technology. So independent audits, like real audits in a much more comprehensive way, is one of the things that we had to do, or we decided to do, in the absence of like having those specific standards that we can be evaluated against.
What are the biggest barriers for entry, or the biggest challenges you guys are facing? Because it sounds like there's a ton of things you have to do basically for yourselves. You have to build any models that you need. You have to gather your own data. You have to put the sensors out to gather those data. There's still also a lot of the manufacturing still that is also involved in creating your own products, even if you are also helping push manufacturing. So what are the biggest challenges that you're facing, the biggest barriers to entry that has been a roadblock and you're mitigating it?
Great, I can start with that. You're both like, yeah. So I think the good thing about us is we actually don't require much to get going with a customer, and the product is a level of maturity now that it pretty much works like we don't actually need any data from the actual site. Like we can get that quite quickly. So just to kind of explain the way we normally do things, so we are full stack ourselves. So we do manufacture the robots as well. We have a big production facility in the UK, and then we ship them all over the world. We've got customers now from like Australia all the way into Mexico and Canada and everything in between. But the robots come in 2 boxes, and it takes literally, I would say, somewhere between 2 to 5 days for a team of 2 of our engineers to go inside, put the robot together, map the initial site by just driving the robots around so they understand and create that initial map.
It's that fast.
It's very, very fast. And that was actually one of the key USPs that we wanted to push with which was like we were going to, first of all, to your point, like we can actually work in any type of warehouse. It doesn't have to be, it's not greenfield, it's like brownfield, actually quite a lot of focus. Like we can come in, there's no infrastructure needed, and within 2 to 5 days, you're actually going to start getting your data and can get going. So I think from our perspective, I mean, we're still a scale up. We're just over like 270 people now and growing quite quickly. But for us, it's just being able to kind of cope with the demand and be able to kind of, just ship the products around, get them deployed and get them going. But if I go back to maybe the customer side of things and the ones that might still be a little bit reticent to begin, normally we're seeing like a very kind of deeply ingrained focus on like pen and paper and like the ways that like we've been doing this for a very long time in this way. Why should we change? And that's why change kind of question is the one that you have to address a lot. But the pace at which that change now happens has been absolutely insane. Yeah, like at least kind of the past year or so, because of the focus on automation, physical AI, on AI in general. So people now understand the benefits to do something differently very quickly.
It's that foreman in a factory who's like, it's okay, I know everything that goes on here. We don't need all of this.
Exactly, yeah. And I think to your point earlier, the conversations kind of being now across all the way from the operational side all the way into the board just help a lot. I mean, without going into too much detail, because I know we're short on time, but for warehousing and logistics, I think the pandemic kind of opened a lot of people's eyes to the fact that there is very little visibility of what happens actually across supply chains. And in order to be able to be resilient if another pandemic happens or something else, then having that visibility and being able to automate a lot of it is going to be quite important. So that kind of narrative has changed so much over the past few years, and we're just kind of seeing it changing at pace.
Yeah, so we were talking about this last week. One of the things that we're doing on the National Security Commission for Advanced Manufacturing and Robotics is working on a national framework for the United States. And some of the briefings that we received, one was from the ARM Institute, which is the Association for Manufacturing, that goes out and pulls data from all manufacturers across the U.S. And they asked this question. They said, the stats are that only 8% of U.S. manufacturers have automation. That's crazy in and of itself. So their study was, why is that? What are the barriers to adopting automation that you are having in your manufacturing facility? And the top reasons were, number 1, access to capital. Number 2 was durable demand signal. You know, if I put this automation in, am I going to have this demand next year to justify it? Number 3 was, I don't have the technical staff that's capable of running advanced automation, installing it, maintaining it. And then the 4th were policies. There was too much flux with things like tariffs or lack of real structural incentives that move the needle. And so when I think about what are the barriers to adoption for Path, we address all of those things with our model, which is probably very similar to some of the others on the panel, with robots as a service. So what that allows you to do is you don't have to have the capital up front. You can use your OPEX expense for labor you would have had to hire in order to fund this in an annual subscription. And that subscription will provide you with the maintenance. It will provide you with the installation paid for as part of the subscription. It provides everything turnkey, so you now no longer have to have the technical expertise on site. And you're using a model that does not require programming. So now you don't have to have robot programmers on site. So you're lifting a lot of those things. But the challenge remains with the incentive structure and the capital access. The incentive structure right now, things like the Big Beautiful Bill, One Big Beautiful Bill, it incentivizes CapEx. Advanced technology that's actually going to solve all those other problems for manufacturing are not sold as CapEx. That's traditional automation. The advanced solutions are mostly sold as a service. It's not deductible. And so now we have these misaligned incentives. So what we need to do is work really hard to get these things aligned appropriately. So we give manufacturers aggregated demand signal across the industrial base, and we give them real incentives that can apply to the technology that actually will move the needle for them. And we need access to capital in addition to that.
Interesting. I think, maybe I can zoom out a bit, talk a bit more about where the industry is at, the physical AI industry. So I see this as, physical AI as an idea and then physical AI as a business, right? So most of the newer companies in the physical AI space, all the buzz and all the excitement is still in the demos and proof of concept stage, majority of that, not everyone, but majority. And think of this as being done in 3 steps. The first one is proving that the technology works, right? So POCs or demos. Step 2 is scaling that, making it repeatable, ensuring that it does what it's supposed to do every time. So that's step number 2. Step 3 is proving out the economics, right? Building the real business in the physical AI space. If I look at the history of robotics and physical AI, there are very few companies that have actually grown to this level of scale that is exciting. So all the, let's say, robotic arm companies that are in industrial setting or automotive settings, they have done well. The other, I would say, consumer robotics company that is a huge success or was a huge success is iRobot. Right. So since then, obviously, we have new crop of robotics companies or physical AI companies, but these are early days. So scaling it, making it repeatable and reliable, and then proving the economics is going to take a long time. In my opinion, and I would love to get everyone's opinion here, it's not going to follow the same scale curve that we have seen in the digital AI space in terms of revenue, in terms of real business, right? So the technology is very exciting, and yes, we have seen a step function change in technology over the last 2 or 3 years in the robotics space. But I think that scale and proving the economics and building lasting and real business, I think that's going to take longer than most people realize. Would love to get your thoughts on that as well, if we have time. Or we have.
Well, we'll have questions a little bit later. I mean, actually, I was going to also pose the question to you. Of course, there's a lot of POCs out there right now. There is a lot of, for so many people and so many other investors, it's like they don't exactly know where it is because there is a very big mix. And I think, honestly, that's my answer. People don't really know where it's going. So I point this question back to you, worded slightly different. I'm not going to ask where do you think it's going or where it will be in 5 years. That's not a good question. But in your opinion, especially in the spaces that you are working with, is physical AI in a dream, POC, in limited deployment, or actual production? I'm not going to say it's widespread because I don't think it is. At what stage do you think it is? And what's one thing you want to move that forward to the next step?
Yeah, I can jump in. Full-on production, bringing real value day after day in hundreds and hundreds of sites with, thousands of hours kind of operation. And I think, if physical AI is a massive term, right? It covers every tiny physical thing that we do. Yeah, it's manufacturing, it's logistics, it's transportation. It's I don't know, it could go all the way down to we're on a stage now, right? You're going to go to theater and you're going to have robots performing for you. I don't know, it's such a big space that, of course, if you say the impact of it is going to take a long time to kind of really understand, because the impact of it can be, fundamental for the human race, right? But if you actually kind of break it down by use case and you understand okay, what is this particular kind of, piece of automation or robotics or technology does in its particular field for their own customers right now, then you're going to find very, very kind of clear value drivers, because otherwise companies are not going to adopt it, right? Yes, you will have your POCs and you will have your innovation teams wanting to do something, but that's not really a business. That's not even proving product market fit if you are to kind of talk in startup terms, right? So I do think, like, yeah, I can see very clearly, and it's not just us at Dexery. There's loads of companies that we interact with on the ground in warehouses and at trade shows that are doing extremely well. They're bringing very, very good value, and they're scaling with their customers because of that value being there already. So yeah, from our particular field, it's definitely kind of like operationalized. Are we just scratching the surface of what we could do with the product? 100%. But that's kind of like the more and more, like with any other product, the more you learn, the more value you can bring.
I agree. It's operationalized and creating value every day. We have implementations all across North America. We are seeing customers that we've had for years coming back, ordering more, installing more. We are definitely not in the proof of concept phase. I would say we have some really cool things in R&D that are coming that are around future embodiments of the same physical AI model. Those things, of course, are going to be a little more nascent. But the core product being out there in the field, delivering value today, that is 100% happening. And I'd also say for us to really look at this and think about what is happening geopolitically, we're in an absolute race for AI dominance right now. And the area that we are leading is in our AI model capability. The area we are lagging is in the hardware and the actual deployments. And when you look at what China is doing with their 15-year plan and what they've accomplished, I was at a round table about 3 weeks ago with the Department of Commerce, and we had some people coming in talking about this 15-year plan, the latest one that's been released. They've spent $135 billion. They're building robo-gyms for humanoids. What are they doing in those robo-gyms? There's 1,000 of them across China, and it's specifically for humanoids to train to build and collect the data. They are going to catch us if we do not take this seriously and we do not get deployments out there. That's how we continue to build our models in the physical world, is to actually have robots working in factories, working in warehouses and in logistics, driving trucks. We've got to continue to lead by collecting the data. And the only way to get that data for physical AI is in the real world. And so either we've got to incentivize and get these use cases and adoption up, or we've got to put a whole bunch of money in building a bunch of robo-gyms. I don't know. I would rather see us do something real practical and useful with it. But we've got to take it seriously, and that's the only way to keep that competitive edge and to continue to lead in this area.
Got him very quick.
Yeah, I totally agree with the points that were made. Like, so we are leading the race when it comes to the model development and the software. Agreed that we need to catch up when it comes to manufacturing, supply chain, and really scaling and operationalizing all the new technology that we have been developing. So I think that's one area that the US needs to continue, putting a lot of investments in.
Perfect. And we are opening the floor for questions. We have about, let's say, apparently one question. So if anyone has that one question, there's technically a mic, but you're one. Yell it out.
And so Joel Stinson, Senior Vice President of the Engineering and Asset Intelligence at UPS. So I play in all of the areas that you guys have been talking about, so I feel like this is custom made for me. But the question I have for you is, in the most recent past, physical AI couldn't really do the job because we had compute limitations and perception limitations. Now that compute and perception have caught up, where I see the problem is the expectation of performance. So there's an operator that says this is what a person should be able to do, and that becomes the requirement for this automated thing. Nobody actually says, but there's only one person out of 80 that are actually doing it that rate. How do you guys work with your customers to really baseline on what actually happens versus getting stuck with unrealistic expectations?
I can probably 100%. I mean, if you go to very specific like cycle counting, everyone was like, it has to be to like 99.99% accurate in terms of give me exactly the number of tiny boxes that you have in this pallet. And to your point, a human will never get to that 99.9 because they'll be like losing count like 20 times by the time they finish it, right? So the way we do it, like we do set ourselves kind of quite high KPIs, and we monitor that across kind of a number of months as we go live. But we keep kind of going back to the value conversation. So we try to kind of take away the customer from like, okay, the numbers are here. It might be not 99.9, but it's 99.8. But actually the total value you're getting by the fact that you're automating that across the entire warehouse, it's not comparable to like this one kind of element that you might be missing. So you keep kind of reminding the user about like what's the actual value of the total project rather than getting them very, very tight to particular numbers. And also you kind of work on getting your numbers quite high. But it's that comparison, as you were saying, that you keep kind of having to work around with in terms of like, yes, out of your workforce, you probably have that one guy that's like a super user, right? But it's that continuous reminder of the total value of what you're trying to achieve.
Yeah, and I would say, Joel, I knew you looked familiar. I remember this problem when I was at Covariant, and we were doing this at WorldPort. And we had this very problem, right? And what I would say would have helped that and other cases like that is to, instead of baselining the exact task that you're looking to automate, you really need to baseline the whole work stream. Because like in the sorter problem that we were working on, where you had a rate that the robot needed to be able to put the packages onto the sorter, you have downstream rates that may be a bottleneck or a throttler, and you have upstream rates to that as well that could be a throttler. And when you only look at the specific rate of the human at that task, you could over-index and make a decision that this task isn't going fast enough as the human without the knowledge that I actually don't have enough people at the back end loading the truck that's going to back up my sorter anyway. So I think helping people zoom out a little bit and look at the upstream and downstream effects to make sure you're looking at the problem holistically instead of what is this human doing on a repeated basis would help.
Yeah, I think from a capability standpoint, taking the time to understand where the technology is actually and identifying what is the right application within your ecosystem to start with, right? Think of this as a iterative rollout of this technology versus overnight change, right? So really taking the time, understanding the technology, and identifying the first step with the highest ROI, and then going from there. So I think that's one thing that we in the autonomous trucking industry, the industry as a whole made a lot of big promises. Timelines have been shifted out, and I believe this time it's real. But for us at Gatik, what we did well was spend a lot of time with the customer even before we had incorporated the company. And that was not very mainstream and obvious back then, especially in our industry. Everyone was promising that this technology would be solved very broadly by 2019, 2020. And for us, we said, okay, it's going to take much longer than that. So let's figure out what's the low-hanging fruit that we can go after that will unlock the right kind of value for the customer, and we can deliver in a shorter time frame and then continue growing from there. So that's basically how we try to deliver value more near-term for our customers.
Perfect. Thank you so much to my panelists for a very, very interesting conversation. And I'm sure everyone has a lot of other questions towards them. When we go down, feel free to mob them. But thank you, everyone, and I hope you have a great rest of the day.
Thank you.